Next greater numerically balanced number. D occurrences of digit D. Well, there can't be that many of them below 10 to the 6th. What should I do? You're never going to have anything above a 7. So I could say, okay, we have from 1 to 7. Could you have 6 sixes? No, because you'd have 1 and 5 fives, right? 1 5 5 5 5 5. That's the, or you could have like 1 2 2 3 3 3. So you're never going to include a 6 either. So you're going to take it, you're going to shuffle them. How do you do that? So if you have, let's go to this. If you have a 1, then you could have 2 1 2, 2 2 1, 1 2 2, and then for 3 3 3, for every one of these you put it in, and 2 2. So it's just permutations of blank. Okay. Sorted map int A. We'll have the empty set. And then for y in A, for z in I'm going to say for x in map, string that. So you're adding like 2 and 2 for z in permutations of x plus y. No, we're going to have that because of the blank set. If length of z no, this is a weird way to do this. I want to say for x in range from 1 to 6, s is equal to string x times Continue, or else add every permutation. Okay, what does this come up with? No, oh, I want length of S. And I'll change this to T. Can't concatenate a tuple to a string. Z is going to be a big tuple. Oops. Three, 2, shit. So what do I want? Permutations without replacement? How many permutations? I could just brute force it. That feels so much faster than this. Right, 3, 1, 3, 3. Whatever, I don't care. From 0, does 0 return 1? Strictly greater, so it's bisect right. Yeah, whatever, let's brute force it, I don't care. Is this for x in, so what I'll do is say check equals lambda def check x, and then I'll say this is going to be filter check and range from 1 to something like 1, 1, 2, 3, 4, 5. Something like that. So check of x, s equals map string x for C and S. For key and frequency in C dot items, if frequency does not equal int of key, return false, return true. Shit, I only went up to 10 to the 5th. So you could have one. Or could you have 2 2s and 4 4s? Okay. Did anybody do it the other way? Yeah, they did. No, I don't know what the fuck this is. That's weird. Did I do this? Yeah. longest balanced subarray 2. Subarray is called balanced if the number of distinct even numbers in the subarray is equal to the number of distinct odd numbers. Return the length of the longest balanced subarray. The number of distinct even numbers. I'm guessing this is more brute forcey. Yeah. Longest balanced subarray. Number of distinct even numbers. That seems not that bad. I think you would just have a prefix sum that's like the difference in distinct even numbers from distinct odd numbers. I think it's a little more complicated because they're distinct, that's going to change at an arbitrary point. But I'm going to kind of use that as a jumping off point. Go from there when I get there. Smallest missing multiple of k. Can it be 0? No. K. Max nums plus k plus 1. Okay. If something... Just check if it's in the set. 10, 5. So what happens if we had like 1, 2, 3, 1? This should say 4. Nice. Okay, longest balanced subarray. So it's going to be something like for every left bound, look through every right bound. Yeah. Number of distinct even integers. It could be 0, right? You could have like 2, 2. Or 2, 3 or 2, 4 or something. Not going to think too hard about that right now. For L in range N. For R in range L to N, this is going to be inclusive. So if length of S1 is equal to length of S2, MSF equals max MSF, R plus 1 minus L, S1, S2 is equal to set. So either of these at A at R and 1. So if it's odd, add it to S2. If it's even, add it to S1. I want the other way around, I guess. Dot add A at R. 4, 5, 3. Lexicographically smallest permutation greater than the target. A little bit nicer. S and target both length n, consisting of lowercase and letters, return the lexicographically smallest permutation of S that is strictly greater than target. If no permutation of S is lexicographically strictly greater than target, return an empty string. So what's to stop you from just greedily using the minimum characters you can? Because if S was like 1, 2, 3 and target was like one. No, you could use, the moment you use something greater, it's just everything after that is smaller. If you use something that is of equal size, then the next thing has to be greater. So I think you could say work backwards. If S was like 4, 5, and then this was like 1, 3, 2, 9, 8 or something, you could say, could you have it so that everything else is the same but not this? No. Could you have it so everything else is the same but not this? No. And then you'd get here and you'd say yeah. Or no, here. Oh, the length is like tiny. So you could just go forward. You could say, can I do it where they're both a 1 here? Which means after this point, there's some number So you'd step forward, you'd say, okay, S, I actually don't care at all what the thing is here. I just care about, for T, do I have something greater than a B? Yes. So therefore I could use that and then everything after this is descending. Or do I have exactly a B? If I have exactly a B, then I'll place that and continue. Okay, yeah. MSF is going to be at the start, I guess Z times N. It can't be any less bad than that. Or Z times N plus 1. I don't even think I'm going to use MSF. I think I'm just going to use res. I'm barely going to even draw any comparison. I only really need counter S. So let's see, for every character, X, I guess, in T, no, not that, that doesn't make any sense. For X in, I could be clever about this and do some sort of weird like sorted S reverse equals true, but I don't want to do that. I'm just going to say for X in reversed ASCII lowercase, because I think it's only lowercase English letters. I was going to add a factor of 26, but that's fine. So count backwards. Is that weird? No, I don't care. I'm not going to try to optimize around that. This is already like way below the bounds. So I feel like I'm almost missing something, that this feels so, the complexity is so lofty. I don't even need to say that. I can just say X equals max C dot. No. I want to say get the smallest character that's larger than T at I. Yeah. I mean, whatever. For x in ASCII lowercase, if, let's see, I want to say, what's the current letter I'm looking at? Val is going to be an empty character if C at x is greater than 0 and x is greater than t at I, break. But I think I'm just going to have the logic here. So now x is the lowest character that exists. I don't even need cur, really, do I? I could just say current equals t up to I plus x plus, I want to say Python counter all elements. How do I do that? Counter sorted, oh, dot elements. Okay, simple enough. And that's almost exactly what I want. Dot join, sorted, and I wanted an ascending order. Then I want to say C at x minus equals 1. C at x plus equals 1 after, because I don't want to include that. That looks pretty good. I break out of that, and then I need the can you continue. So if C at T at I, this is saying if you're at the first letter, do you have a B? Because if so, you can continue down, and that could be the lexicographically smallest. So if C at T at I, C at T at I minus equals 1, else break. This means you can't find anything lexicographically smaller. I think I could just say this is res. There's no reason to have cur. Method object not iterable. Oh. BCA EELT BBAA. Doesn't come up with anything. Whatever, we'll see all of it. Nice. Those are usually a serious weak point for me. So where the balance of the number of distinct even numbers in the subarray is equal to the number of distinct odd numbers. Wow, nobody got this. Holy shit. Okay, so this is what it was about. So if you had 1, 1, 2, 2, well, what's the constraints? 10 to the 5th. So that means it's pretty much guaranteed to be linear, logarithmic, or n square root of n. Not answering that. Okay, there's an immediate thing that I feel is important here, which is, no, it's not that important. No, it's not important at all. Well, it's kind of important. Nums.i only goes up to 10 to the 5th. So there's a world where you care about that. You care about each individual nums.i. The problem is like the times where that would be useful are if you're bucketing, which doesn't make any sense here, or if you're doing some sort of harmonic series thing, which also doesn't make any sense here. Number of distinct, number of distinct. You would normally, for something like this, you could do it in linear time with an exclusive, with like a prefix sum and exclusion property, but you can't really do that here. Or can you? Could you say, how far back do I go before I don't have this many exclusive numbers? That would require monotonicity. Which is there. The greater the length of the subarray, the amount of distinct even numbers or odd will only ever increase. What if it's a binary search? What if you say, can I have this many? That doesn't sound right. So you have A. And then you're saying like, what I ultimately want is something that's like, you are here. Can you do better than you've previously done? Or like, what's the maximum? And ideally what that would look like is you'd say, what's the furthest back I can go where I have the exact same differential? So here you'd say like, okay, well I have, or let's say like you have 5 here. You'd say, okay, I have 3 distinct odds, 2 distinct evens. You'd want something that says like, if I just go back to here, this is the best I can do from this location where I'm including this 5. Where I have 2 distinct of each. But how could you possibly get to that index? I think what you could say is that, okay, what if you had a series of decks where you said every offset is a single deck, and you would add this index is, you have if you said this index is, you have an offset of 0 from the even and odd integers, and then this index is, you have an offset of 1, but then you see another 1 and you say, okay, well also here is an offset of 1 and I want to move this 1 up. And you would also say, because every time you encounter a number, you're moving the deck up to the next thing, and you're moving that 1, which here would be the same spot, you're only ever going to have exactly one spot in all the decks for every number. There's only going to be O of n elements total in all decks. There can only be O of n decks. So the time complexity is fine and it's linear. You just say, every time I see a number, look in a dictionary for the last time I saw that number, what deck that's in, move it up. Okay. So if you had 1, 3, let's say 1, 2, 1, 2. You'd say, okay, offset of 0, offset of 1 is here. This gets added to the offset of 0 deck. It's really negative 1 and 1. And then this would be, you'd say, okay, now wherever the 1 is, I need to pop that from its deck. So this is gone. Which means at this point, there's no way you can look backwards and have exactly one distinct number. You will always have at least 2. No, that's not what that means. It means there's no way you could have an offset of 1, but that's not true. Okay, and then you'd say, also here is an offset of 2. And then you get to the 2 and you'd say, this is out of there. And then you have a 3. And then you'd get here and you'd say, now I do have an offset of 1 again. But I think from here you'd say, no matter how far back you look, there's no way to get the same number of distinct. No, that's not true. You just immediately look here. No, this falls apart. Is there any way to do a divide and conquer approach? You have all these. How many distinct numbers are there? You could get that for any given query in n log n. What's the difference in distinct even and odd numbers? You could get that in n log n for any given range, because you'd say on the left side you have some distinct difference and a set, and on the right side you have a set. You just combine them, you get your thing up, you get your set up here of even and odd numbers, take the difference in the lengths, and if you're smart about it you can combine by size and you can get log n. What does that afford you? that affords you any well, this is just any power of 2. No, not necessarily any power of 2. This can get you any query for any subarray in n log n, which is fine. So you could just kind of build a big segment tree. Or I feel like sometimes people call this almost like an order statistic tree or something. So you could do that. And then the next question is, are you able to kind of able to just attach a query to this that's like, okay, given some set, what's the longest in either direction? So I guess what that would look like is you would say, okay, each node in the segment tree is going to have a few things. It's going to have the even set, the odds set, and then it's also going to have like x, the largest subarray, such that within this section here, such that the even of the left side, no, that's really weirdly written, such that, I don't know, the evens of the subarray minus the odds of the subarray is equal to 0. And then you could aggregate that, because you could say, okay, well, given my subarray, like I have this whole thing, x for a given u is just going to be x for like the left child and x for the right child. I wrote this kind of weird, but the maximum of these. So if there was a subarray in here that was pretty big that had the same number of evens and odds, and the subarray in here that's some size, you take the bigger of those, and the only thing that doesn't account for is some subarray that straddles the center, and then you would need a smart way to traverse that. That's the only missing piece. You would need to do that in less than O of n. So given a partition, what's the maximum size of a subarray across that partition? That includes the same number of even and odd integers. I don't know. I don't think that's doable in O of log n. I think you would need to like parse the entire subarray. Maybe not. Maybe you could. No. No, you could. You could say, I have a set on this side coming from this way and a set coming from this way and a set coming from this way and a set coming from this way. If you're combining left and right, you would look at these and you would say, you would need a prefix maximum of, maybe if you used a segment tree for this, but that's really, I mean, then you're in like a weird 2D segment tree land. Yeah, I don't think that's a good idea. You'd say, coming from this direction, what's the maximum ratio or minimum ratio of evens to odds, and the maximum or minimum ratio of evens to odds over here? And then you would just take the minimum of those. Okay, I've returned. Let me see if... Okay, yeah, this looks good. Couldn't solve D. I saw people were saying B was... I mean, like, random people on Reddit. Where it seemed like a weird one where, like, random people could only do A. Couldn't solve D in the last Codeforces contest when I got the correct idea 45 minutes in before the end because I just couldn't debug. That's rough. Nino Kuni. There's this one dude I used to really like. This guy. Let me find a good one. No, none of these. Yeah, one of these. I'm gonna pause this for a second. He just like does like Vocaloid piano covers, and they're like, I remember when I played piano a lot, I was like, damn, this guy's cracked. Kokoro no Kakera. Hey, Urinator. Be straightforward. Man, I want to look at the Codeforces contest. Should I just drop this? Should I just say, you know what, fuck it. Due to lack of willpower and possible lack of intelligence, I will not be doing Q4. I'm gonna accept my whatever crappy ranking this is. BCD were all nice problems. If you guys all told me like you'd prefer for me to just look at the Codeforces, I kind of want to look at that. But if you said you didn't care, I want to stick with this. If you get to E, you solve a Leetcode problem as well. Buy and sell stocks 5. Just playing like Bad Apple and stuff. Okay, so I'm thinking, I feel like there's one more thing. So the number of distinct integers is idempotent. I can say that if I knew, say I had a prefix sum and I said right here, you had the last 6, or you had 6 like distinct integers in this range. Yeah, when I think of Toho music, I think of just like Vocaloid music. Just do Codeforces instead. Okay, yeah, fuck it, whatever. Goodbye, average virtual score. I guess only 111 people got that, so to be fair, like, it's probably still a pretty good score if I finish the rest of them in like 15 minutes. I forget if 165 meant if I finish all of, like I still have the possibility of getting 165 if I did all of them, or if it means if I just stopped right now, I'd have a 165. It looks like if I stopped right now, I'd have a 165. That's what that's telling me. So I'll take it. Probably pump my score anyway. Oh, you know what though? Did this like just end? Because I find with Codeforce, was it this one? Or no? $10.35. Because I find like Codeforces is just bricked after. Oops. Yeah, that's pretty bad. That's pretty atrocious. I don't know if I'm gonna be able to do it. Is it still calibrating too? Title in Ranji, 2 million medley. I think it's just this dude like playing a bunch of random stuff. Come and go back to Ghibli. Would you consider switching to Codeforces more than Leetcode? I already have. I do the weekly Leetcode contest, but whenever I'm coding past that, on these sites, like I just do Codeforces. Pretty sure it's from Toho. I think it's called Bad Apple. I know Bad Apple's like the really famous Vocaloid song. Okay, can I... I'm gonna not look at anything, but can I submit? I can submit, so... How long is a virtual? Yeah, whatever, that's fine. No virtual participation is allowed now. What the hell is that? Why not? Wait, what? It was right there. Oh, system testing? Do 1060. If it says system testing 100%, does that mean it's all? Does that mean like any minute now? Oh, not the URL round 1060. I am like, this is the one people just did, right? So I feel like that. I mean, if I can't do the virtual for 1061, I guess I'll do this, but no, I don't really care. I feel like doing 1061, right? If that's the one that everybody just did, I feel like that might be more important. But this is also really slow. I might go back to Leetcode. I might salvage my 165 placing. I don't think it would be this. I don't think it's going to be some sort of like index offset. Because if you say like the offset is 4 here, there's 4 more evens than there are odds. And then here you have like also 4 evens and odds. I don't think that actually tells you anything about this range. That does not mean that this is 0. It would if it wasn't distinct, but... I don't know. It says start virtual. Am I crazy? Can I... There we go. Okay. Alright, well, fuck that other question. Yeah, this is what I like to see. I think it said like pizza GCD or something, so I'll start thinking about what the problem could be. Let's get those all loaded. Pizza time. Hal and Alex are good friends. After winning coding competition together, they receive pizza as their prize. Initially, they're given n slices. If there are at most 2 slices remaining, Alex eats all of them. Otherwise, let m be the current number of slices. So Hal eats the smallest group. Alex eats the middle group. And then the largest group is what gets left over. So why would you not always split it into 1/3? I think that you would always split it into 1/3, and that's why this is an A. So let me run through these. For 8, you would say divide it into thirds. That's going to be... No, would you even do that? I don't even think you would do that. I think you would say, you can do better than that. You could just always split it into halves. And then make sure you would have like 1, 1, and then the rest of it. So you'd say 116, 114, 112. So is it just at -2 over 2? Rounded up. So 8, you'd say the final 2, you just don't get those, that's fine. And then you get half of these is 3. Okay. What about 5? You could say 1, 1, and 3, and then 1. I think it's -1 over 2 rounded down. Because here you could say 1 and 1. You get the 1, and then 1, 1, 1. You get the 1. Okay. So if I try some really big number like 117, which is divisible by 3, I don't think that matters though. You could say, okay, 1, 1, 115, 1, 1, 113, and so on until you get all the way down to 1, 1, and 3. And then you'd have 1, 1, and 1. And you would get to take all of these. So under my rubric, that should be -1 equals 116 over 2 is equal to 58. So that's what should happen. You say 115, 113, all the way down. And it looks like here you just kind of like, yeah, it's literally just did over 2. So I'm pretty sure that's it. How big can the number be? Not that big. Oh, it was a Night of Nights. You know your anime music. I used to be so into that. So according to this, I should just say print X. And this should kind of just do everything. 311. Worth a shot. It's not the most rigorous proof of my life. Was that even a proof at all? Or was that just kind of like completely vibes in it? Okay. Strange machine. You're given n machines arranged in a circle. N is at most 20. I know the melody, but not the name. I know, I think something's wrong with my brain because I cannot for the life of me understand lyrics to songs. Each machine is either of type A or B. The machines are numbered clockwise from 1 to n, and the type of the ith machine is denoted by S sub I, which I'm guessing is 1 or 2. Oh no, it's literally, it says A or B. Okay. Each machine takes an integer x and updates it according to its type. Decrease by 1. Replace x with the floor of half its value. So divide it by 2. You're given q queries, each consisting of a single integer a. In each query, you start the machine at 1, holding an integer a each second. The following 2 actions occur in order. The current machine updates A according to its type. Then move 1 step clockwise. This process continues until your integer A becomes 0. For each query, determine the number of seconds it will take. I see. Okay. Well... You can only divide it by 2 a logarithmic number of times. So I feel like you just kind of look at... I think you could almost just brute force this. I think you could just literally brute force it unless every single thing was A, in which case you need to like just return the number. I don't see why it wouldn't be that. Because every time you encounter a B, you're dividing it by 2. You can only do that so many times. So what's the worst possible case? You give it 10 to the 9th. You have you have 19 A's and a single B. So it takes you 19 times of basically like a completely negligible change. And then you divide it by 2. Negligible change, you divide it by 2, and so on. The sum of Q only goes up to 10 to the 4th, so that should be like completely fine. Yeah, I think that's fine. Okay, we got test cases, and then you get N and Q. I guess I see why this one would like trip people up that are new to Codeforces. Why would it trip people up? I think what happens sometimes for people that are like new to these kinds of things is like you see. I think it's I think it's pretty easy. But I think what happens is you see a corner case. Well, I think there's two things. I think first things first, you see a corner case of, well, what if they were all A and this is 10 to the 9th? And then you go, well, shit, okay, I need to think of some smarter way to do it, when you don't, because that corner case specifically is accounted for. And like splitting into that corner case and everything else doesn't come easily to people. And I think when the skill of like splitting your schema in half and going, okay, what I was thinking is still the case, but now there's this corner case. Like, I think that people, if they're not well versed in that, they'll just throw the whole thing out. And I bet a lot of people did that. I think also noticing I can do blank and the reasoning why is confusing. I think that's also hard for people compared to like implementing Dijkstra's, which is more confusing than this, but like the confusingness is in the implementation, not in like the reason why it works, if that makes sense. I think people have an easier time with that than like return x plus 1, but the reasoning's really confusing kind of a thing. Okay, let's get S. And then let's get Q going. What do I want to do? Am I printing line by line? Yeah. Something like that looks pretty good. Okay, print res at I. So input N. I want to test first. Can I say like print, or no, I'll say like bool test equals S dot contains B. Get rid of everything else. Does this work? I still want to have this one. 1, 1, 1. They all contain a B. So what if this was AA? Is it like, does it know what? Okay, perfect. And that's pretty much that. Valid is S dot contains B. Right? If there's no B, then you just, it's pretty basic, right? 3 you'd say decrease by 1 you have 2, divide by 2 you have 1, decrease by 1. No. 3 is, oh no, because you're dividing by 2 first. Okay. If valid, else res at I equals N. Res at I, I'll say int x equals 0. What the fuck? Okay, x equals 0. 20 times 10 to the 4th times 30 could be too slow. That's like 66, so I try to compute the group by of S. It turns out this wasn't necessary. That was the one optimization I was thinking about, was you just say, where are the divide? That's what I would do if this could be a very large size. If they made this be 10 to the 5th, I could see this being, I guess, also a div2b, where they say the array itself could be up to 1 million elements. You can't just brute force it, because like, what if there's a single B and 999,999 A's? Then you can't really just cycle. In which case I would do, it sounds like what you're talking about, of just say like, okay, we'll subtract 900,999 and all that, and then divide by 2, and then do it and divide by 2. X equals 0, while, I'm going to do this so basically, I don't care. While n doesn't equal 0. Does this make any sense? Or do I say for x in... I'm not going to do while n equals 0. I'm going to say for no initializer, n is greater than 0, x plus plus, or I'll call it I. And then this will be n equals s at I percent s dot size is equal to, no, what am I doing? This equals a question mark n minus 1, or else n over 2. You just keep doing that. And then res at, oops, whatever. This is x now. It doesn't really matter. Or kb's in a row, you do x bit shift by k, yeah. 235258811. 235258811. Here's hoping it's just straight up that. I don't really see why these test cases wouldn't. At 95, that seems kind of... large enough that it's going to capture whatever problem is there. The only other thing I can think of is if I like didn't implement or else do this. There we go. Maximum GCD on whiteboard, you're given an integer k and n positive integers a through n. Written on a whiteboard where a is less than n. Choose an integer from the whiteboard and erase it. Do that at most k times. Choose an integer x is greater than or equal to 3 from the whiteboard. Split it. Okay. Then erase x from the whiteboard and write 2 new integers, x1 and 3 on the whiteboard. Seems weirdly related to A. The beauty of a collection of integers B is defined as the greatest common divisor of all the elements in B. Formally, it's the largest integer D, such that D, okay. The GCD determine the maximum possible beauty of integers after performing at most k erase operations and any number of split operations. Interesting. I tripped on this one because they don't tell you whether you can... They don't tell you whether you can do the operations in any order. I guess I assumed it was, yeah, I don't know. Would it matter? Is there, like, when would the order matter? Couldn't you do all the splits first and then all the erases? Or all the erases first and then all the splits? Like, you're only ever adding elements with split. Oh, I guess because they listed erase first. If you wanted to split and then erase, that kind of matters. I'm thinking a split and then erase is the same as just subtracting a number. So if you said I'm only ever going to split and then erase, you're just going to subtract a bunch of numbers. You're never going to add any number. The closest you can get is deleting small numbers. So if you had like 1777, you just delete the 1. Light mode, I know. I think when I'm in... Yeah, this has sweet, sweet dark mode. But I don't really like Chrome. Well, K is going to come down to exactly 2 things you can do with it. You can either just straight up get rid of a number, or you can use it in conjunction with a split, which will always become you subtract that number. I think there's no reason why you would ever split more than once. So then the question is, no, not the question is, you get either, is there any reason why you would ever split and not erase? No. Because like, let's say you had like 6. And then you had 5, 5. You're not going to split to get some factor that's already here. So you're only splitting to change it. So like to get a 5 and a 1. But then necessarily if it wasn't divisible by that, and you're subtracting by some amount to make it divisible by that, then the amount you subtracted by also wasn't divisible by that. So you would need to get rid of this. So you can never make it divisible by a number and have the other thing also be divisible by that number. So I think you're only ever going to want to split and then erase. There's never a world where you care about just splitting just because you can. Yeah. Well, yeah, that's true. Okay, that's important info. So that means you only have K operations total you care about. And the K operations are either, you really have 2 operations. Split? No, not split. That's what I was just saying. 2 operations you can either erase or subtract. These are the only 2 things you care about. So then it comes down to when would you erase and when would you subtract? Well, anything greater than a GCD that you care about, you just subtract to the GCD, right? And anything less than the GCD that you care about, you just get rid of. Unless it's divisible by the GCD, in which case you just keep it. And then there can only be like somewhere on the order of n root n, n log n contenders for a GCD, because you would only ever use a GCD that is a number itself or a factor of a number. So then you could just go through all those possible options and say how many numbers are above it or below it. I think I might be overthinking it. I think even that, it doesn't really matter. You could just say like, with one operation, you can either just get rid of a number or subtract it. Splitting, I think, will just never matter. I don't think there's even any reason why you would do this ever. You just erase every number that you don't care about. So then you just say, like, choose a number where, like, I think this is just a huge red herring. It doesn't matter. No, that's not true. No, I missed a huge thing. X2. So you could have either... No, okay. I completely missed that. I think, though, that's not the end of the world. I think a lot of this still holds. So you can either erase or subtract. If a number is at least twice the GCD that you're targeting, then you don't need an erase, because you can just say split it into 2 of the GCD that I care about. If it's not at least twice the GCD, then you do need to erase something. How large can these numbers be? They are not that large. So actually that's great, because that means I feel like you could almost just try every single number. You say try every number. How many numbers are not divisible by this? Yeah, you could do a harmonic series divergence. You could say, if you have all these elements, you say try 2. Okay, look at every other number, like how many are there up until you get to 4. And then once you get to 4, everything here can automatically be converted to that. And then how many numbers are less than it, which is just like the number minus 1. Or no, how many elements are less than it? Okay. Can I be smarter than that? That feels like annoying. I don't like writing out harmonic divergence stuff. You convert it into a frequency array, where you just say this is the frequency of numbers at this element. And then you have a prefix sum. And you say how many numbers are between these 2 things. And then you say everything that's below a at I times 2, you have to get rid of. And then you count up a at I. Oh wait, no, yeah, you don't even need a harmonic divergence thing, do you? Because you are only ever counting exactly a at I, and then everything below it that's not exactly that. Okay. In that mind, you can do this kind of in linear. So you'd say, look at every possible GCD. How many numbers are below twice that number that aren't that number itself? Everything above that, you can account for free. Because you just get rid of, you just make it equal to 2 times this. Everything that's below it, you have to erase, because you can never have a GCD, you can never increase it, so you have to just erase that. And everything that's between it and twice it, you have to do some sort of split and erase, or erase itself. All right, I think I'm ready to write it out. How confident am I in this proof, though? With A, I really didn't think about it at all. With this one, though, I want to at least be a little bit more. I'm certain that none of these will ever affect the GCD, anything greater than it times 2. I'm certain that the number itself will never, you never have to erase that. Then I need to prove to myself that you must erase something for these. You must erase this, that's true. For this, there's no way to do it with only splits, therefore you must erase it. Okay. Yeah. So what do we got? N and K. Whoops. Maximum GCD. Two times 10 to the fifth. A at x plus plus. So we'd say there's a 1 in the 2's place, there's a 2 in the 2's place, there's a 1 in the 4's place, and so on. I don't really need pref. That's kind of redundant, but I don't really care. Partial sum, I think it's A plus N, pref. Shit. Long int to long double. Oh. So it's saying we have 2 2's, we have 1 4, and then pref is correct, okay. For I from 0 to, I guess, n, but probably 1. So MSF is going to be the minimum number needed. So current equals pref at I times 2, but minus 1, because you're going up to anything 4 and above. If you're trying to make 2 the GCD is already valid, you don't need to do anything, so you're going up to 3 minus A at I. You don't need to make 2 into itself. What was the point of this? What am I even trying to do? Maximum beauty of elements written on the whiteboard after performing the operations. Largest integer d such that d divides every x. So it's not MSF is min of MSF incur. I know, for a while I used to not do the bit shifting because some Larry yelled at me for it, if you know him. And then I was like, nah, screw that, I'm gonna do it again. Just because I'm not certain of this, maybe GCC just gets around this, but bit shifting is like basically instantaneous, right? But multiplying seems slightly more complicated. Maybe not though, maybe it's also basically instantaneous. If cur is less than or equal to k, res is I. And this is res because I like that more. Two, 1, 5, 1, 3, 1. Okay, huge numbers. How is that happening? I think it's happening because I'm saying for I in range. What's happening here? I'm saying 8, which is not right. 1 0 2 0. That's right. You don't, as far as my estimation, you don't have to change anything to make all, you don't have to erase anything to make these all divisible by 2. 3 3, you need to get rid of 2 2s and a 4. There's no way around it. 8 says -2. I think that's probably because I'm just going off the edge. Pref at I vat -1. I is... I think it's gonna be that, right? Or greater than n. Let's see, if n was 4, you could have 1, 2, 3, 4. If you're looking at 2, you would want to include that. Am I crazy? A continue, oh, return. So it said 8 is -2. Six is saying -2. These are all 0. Oh no, I don't want 0. I just want pref at n, I think. Right? Yeah. Pref at n is not 0. Oh, I think it probably is 0 because I need n plus 1. Okay, good old-fashioned debugging. 225230, 215131. So why is this 1? Yeah, according to me, you could immediately have this be 2, right? No. I think it needs to be times 3. Because x2 is the middle element. Not any specific element. So let's see, if you had 5, you were trying to get it to become 2, you wouldn't be able to do that because you'd split it into 2, 2, 1. You have an element that's smaller. I think even in that case, I think 4 doesn't work. Because you'd have 4, a non-zero number, and 2. So what happens if I do just say times 3? still saying that could work. So 6 is not an issue. Are you able to turn 7 into a 2 without erasing anything? Or things divisible by 2? I guess not, because I guess you have 2, 3, 2. Or like 1, 3, 3, which you don't want. 8 is already divisible. 9, can you do that? You need one of them to be the GCD number itself. You need one of them to be larger than that, greater than or equal to that, but it's going to be larger than, because if these were all equal, then you wouldn't be dividing it. So you need to be greater than or equal to. And then you need x3 to be larger than that. And you need this to also be divisible by the GCD number. So this is going to be the GCD number, this is going to be 2 times the GCD number, and this is going to be the GCD number and change. So any number, I think it's 4. I think any number greater than or equal to I times 4 is valid. So this is going to represent, for any potential I, what's the total amount of elements that you need? Oh, and I also need to say a minus equals a at I times 2. And a at I times 3. Two 5 3 3 0. So let's take a random example. Let's say you're trying to make your GCD be 3 and you're given like 34. According to me, you should always be able to turn this into multiples of 3. Or even if it were like 13, you should be able to do that. Because according to me, you have x1 is 3, the number you're throwing out, and x2 is 6. And then this has to be greater than or equal to 3, and it's going to be 4. You throw this out, now you have 2 numbers divisible by 3. But if you had 11, you wouldn't be able to do it, because you'd say 3, this is 6, all you have left is a 2 to get rid of. But if this was a 3, you'd have to get rid of exactly a 3, that doesn't work. Why is this -1? No, that's right. Is there any world where I'm overcounting anything? No. Any number times 4 is not going to be the same as any number times 2 or times 3. They're all non-zero. write times 3 in the bracket. Two one five one three zero. 215131. 10. The answer is 1. So what's happening here? I should say there's a 1. The total number of elements less than 4 is 1. Take away 1. Don't do this, don't do this. So cur should be 0, which is less than or equal to k. So res should be equal to I. I think it's actually that I want this to be n plus 1. That's really good. I tested that corner case. Because if I had something that was like that, and I said n, that would give some weird answer. 0. But if I say plus 1, it's like, oh, okay, you have a bunch of 7s, so you're good. Four. I think I maybe miswrote this. One, two, three, 4. Why does it stop at 4? N is 4, K is 1. Oh. Oh. This is because, yeah, I just miswrote how that works. So it's saying 7. This should say 0, though. Or 1, yeah. So plus 1, res is always 1. Okay, I think it's good to go here. Two, 1, 5, 1, 3, 1. Okay. I kind of like that one. I spent too long on it, though. Interactive problem. Hidden permutation P of length n. You're allowed to interact with by asking the following query at most 2n times. 2 integers I and x. The grader will respond 0. P sub I and x is equal to 0. It's better than D. And 1 otherwise. So you're gauging for set bits. Your goal is to determine the value of the last element of the permutation P sub n using at most 2n queries. You cannot make queries involving the element P sub n. Ah, I see, okay. I think if you could query every you could be like, what's So you could query every, let's see. Let me look at like an actual permutation here. Permutation of length n. I'm gonna assume it's like one. Yeah, okay. So I kind of have an idea. I feel like there's maybe some sort of pigeonhole principle thing going on here. So let's say you have like, oh my god. 5, 3, 4, 2, 1, 6, 8, 7. I don't know. Maybe like this. Or this is your permutation. So we've got 1, 2, 3, 4, 5, 6, 7, 8. So you're looking for the number that's here. I think one bait thing you could do is say, well, if I knew the number of every other spot, then I know the number here. But I don't think that you want to do that. I feel like what you could do is say, is this an 8? Is this an 8? Is this an 8? Is this an 8? Yeah. And I think what you could do is query, you could say 1 1 1 0 1 1 1 1 1 1 1 1 1 1 1. And then you'd say, okay, I'm going to gauge every single number that has anything that's not 8. At least in this example, I'll say that. So you find the 8 somehow in O of n queries, basically, and you say, aha, it's right here. And then maybe you use that info somehow. But I might be barking up the wrong tree. No, because, well, maybe, but this, then you know this can never be 8. So this has to reference a number that will eventually come back to this number, which will then go to 8. So maybe there's a way to, in O of n, go backwards. I think there's some problems with this strategy though. First of all, 8 is a power of 2, so it's simple enough to get this number, but if you had a 6 or something, then it's going to be more complicated than that. The grid will respond if pi and x is equal to 0. Well, I guess you know. Don't you know the exact number of set bits? If it's truly a permutation, like you know that this is just 1, 2, 3, 4, 5, 6, 7, 8. You know that's the case. So you could say, okay, for the 0th bit, what's the 0th bit? And then you'd say, okay, we'll test all of these and 1. All these and 2, but then that's n times 32, not n times 2. Zero if p sub I is and x is 0, 1 otherwise. The interactor is non-adaptive, okay. Man, at most 2n times. if you have info on a number that, if you say this is the 8th, this is where the 8 is, I'm looking for the 8th index. Can you do anything with that information? You could say now look for the 7th index, but immediately you could get into some sketchy territory with like, this is an 8, this is a 7, this is a 6, this is a 5, and then that's like O of n squared. Can you garner information? Yeah. Okay, I think what you could do is you could say, screw the whole pigeonhole principle thing, that's out the window. The going bit by bit is probably the way to do it. If I go with that for a minute, you could say, you know there's a certain number of set bits. So you know there's exactly 4 numbers with a set 1 bit and 4 numbers with a set 0 bit. And then there's what, four, what would it be? 0, 1, 1, 0, 0, 1, 1, 0. So there's exactly 4 numbers with a set 2 bit and 4 with a set 1 bit, and then 0, 0, 0, 0, 1, 1, 1, 1. There's exactly 4 numbers with a set 4 bit and 4 with a set, with a not set 4 bit, and then you have 0, 0, 0, 0, 0, 0, 0, 1. So here for the 8th bit, there's 7 numbers with a not set 8-bit and 1 with a set 8-bit. So then I think what you could do is you could query each of these bits, remember which ones are which, keep a pool, and say, okay, if I just looked at the first 7 numbers, how many of these have a set 1 bit? You'd be able to say this has a 0 set bit, because there's 4 with a set 1 bit and 3 with a set 0 bit. So that's 7 operations out the window. What's my time here? An hour. And then you'd say, okay, of everything with a 0 set bit in the ones place, only look at these numbers, which is going to be around half. Yeah, it will necessarily be half. Rounded up possibly, but you're going off of n-1, so it doesn't really matter. And then of these 3, you know now you have 2, 4, 6, and 8 as contenders. But you don't know which one's placed where. So then you'd say, okay, for the 2's set bit, you just know how many of these even numbers have a 2 set, which is 3 of them. So you'd measure these, you'd say 1, 2, 3. I have a 1, a 0, and a 1. No, 2 of them. So this must be a 0. So then you'd get rid of the 2 and the 6. You'd have just the 4 and the 8. You'd say, okay, there's a single set bit. And that has not a set bit. So you measure this, you'd say it does have a set bit. Or it does have a set bit. Therefore the other one must not, therefore it's 8. And you did that in 3. Here you measured 11's less than 16. Okay, so you have to narrow it down each time. You're only looking at the total amount. So I need a quick way. I think I need a quick, no, I don't even need a quick way actually. Because this is constrained by 2 times 10 to the 4th. That's actually like really lofty. So I just say count through every single number. Check if it has a 1 set. See what I'm missing here. Be like, aha, okay, I had 1, 2, 3, 4, 1, 2, 3, 4. I had 4 1s, but only 3 zeros. Therefore, I'm looking at a number. I'm missing a number with a 0 set bit. So look at all of those. That's O of n. I can just kind of say again, like, does it fit the bill? O of n, O of n. And I think, like, per row, it doesn't even matter. Oh, boy. Test case, so input n. And then I can say question mark and then exclamation point. So I think first things first. VI, TMP, canned, iota, should be 1, 2, 3, 4, 5. I guess I just go through them and then I build out the number that I'm looking for. I need a way to really quickly say, for a given set bit, how many numbers less than or equal to n have all those bits set, have that given bit prefix. I think that's fine though. I think I can just completely brute force it. So I can just say int res is equal to 0 for bit in range. Or no, I'll just say int bit equals 0 while can dot size is greater than 1, do something bit plus plus. I'll have this be the actual bit. And then I'll have this be the prefix. I'm gonna grab some water. Okay. So I think the first thing I'm doing is I'm saying how many set bits am I expecting? For every x in the candidate numbers, I should be able to just say candidate is 0. No, I don't want that. For every x in the candidate numbers, I guess it's a little, yeah, I think the music's a little loud. If pref and x doesn't equal pref, continue. This number, we're already ignoring it. If O plus equals, oops. Pref, no, not pref, x and bit is equal to 1, is equal to bit. So look at how many numbers are there with a set bit here. And then you need to test all of those. I think I don't even want to do that. I think I just want to have O and Z. O dot clear, Z dot clear. So push back the ones. And then I also run a query on all these. I guess it's a little confusing because like the numbers in the array can be just random. Yeah, I think I have a solution. I think I'm like halfway up. I'm halfway to coding it. So then I'm going to go through all of the indices that I care about. So if it was like 1, 2, 3, 4, 5, 6, 7, 2. So if I had this, I would say you have every single number as a candidate. Look through all of them. You're going to have a certain amount of set zeros and not set zeros. You're going to say these indices are still the ones that I care about. So I'm going to have candidate and also candidate set indices. No, I think there's a much easier way to write this, which is I don't print, like candidates doesn't represent all the candidate elements. It represents all of the candidate indices. Candidate, that looks good. This is going to be from 1 to n. That should be good. No, this should be n minus 1. Get distracted. We get the prefix, we get the bit. I say, okay, everything where there's a 1 there goes in the O bucket. Everything where there's a 0 there goes in the Z bucket. I'm going to say for int I in canned, print something, cout.flush, and then this is going to be something like question mark IX. Try querying it with X. Simple enough. And then we get X itself. I don't think there's any if pref and X doesn't equal pref. That doesn't matter anymore. So say for this index, does it have this bit? If X equals 1, push it to the 1s, or else push it to the 0s. Okay, that's all I have to do there. And then I need to see then I do actually basically just do that again. This was the part that actually mattered. Let's see, let's grab this. Oh man. for int x equals 1, x is less than or equal to n, x plus plus. It's gonna be something like that. So set bits is 0. Look for the total numbers with a set bit that we care about. If set bits is equal to 1's.size, this is saying you've accounted for everything with this prefix that has a 1. So then candidate.swap 0, else candidate.swap O. It's candidate.swap 0, and then pref right here, pref XOR equals bit. This is saying it does have a 1 set bit here. We have to look at that. I think I need to be more explicit with the prefix, because for example, if my number was like 17, then this is 1 0 0 0 1, and if I was like here, the prefix is just a bunch of zeros, and then there's something here. But that's going to mess up, because whether this is a 1 or a 0, it's going to be the same thing. So in the end, I would wind up with a 1 and a 17, but I don't really want to do that. So I need to be more explicit with my prefix. I think I'm just going to have prefix literally be what am I doing here? So this is the candidate indices. I say you have a 1 or you have a 0, and then I'm saying how many elements in all of these candidate indices candidate numbers begin with exactly the prefix. So I think I could just say like valid equals true. While bit 1 is less than bit, do that. Yeah. If something valid equals false. If The implementation is a bit tricky for an interactive problem, yeah. If x and bit 1 doesn't equal the prefix and bit 1, okay. I'm happy with that. I thought I was gonna have to do some really bullshit like int and lists conversion stuff that would be a nightmare. But this should be good. This should just say like, does it exactly match? Maybe there's some function in C++ that does this, but whatever. So look at all the candidate indices. They're either going to go in the zeros bucket or the ones bucket. For every index in the candidate, say, does this match with the current bit? Get the match, put it in the ones bucket or the zeros bucket. Now you have like all the odd integers, all the even integers, and then you need to say how many odd and even integers should there be under n. So say, okay, look at all these, say, does it exactly match the prefix so far? Is it a number that could be the final number? So say it is, and then say for every bit, does it exactly match the prefix? Okay. And then this is now if not valid. Okay, set bits plus equals bit and x equals bit. So is there a set bit here with x? So it has the correct prefix and there's a set bit here. Okay. So if set bits is the number of elements that you tested that have a set bit here, then you know you've accounted for all of them. Therefore, the correct answer has a 0 here, or else the correct answer has a 1 here. So these are the new candidates. And you need to change the prefix. And then in the end, I guess I'm just choosing the prefix. Is there a world where this like goes one short? If you said there's no more candidates at all, that would mean that you changed this to a 1. If set bits doesn't equal o.size, that's where you go here. I don't know. Looks good to me. Is there a world where you get in an infinite loop because you just keep choosing zeros over and over again? I don't think so. Oh boy. Okay. So I have no real way of testing this. I don't even really have a way of testing if this is like valid at all. If this like doesn't just immediately crash, I have no idea. There we go. A bunch of that. Does it at least not crash? So it said the right answer is 0. Does that make any sense? Yeah, that kind of does make sense. Well, let's see. Let's say there's one test case and 7 numbers that we care about. So there's 1, 2, 3, 4, 5, 6, 7. It should say you kept choosing a bunch of 1s. I think at some point it should just kind of like crap out and say the prefix is 0. Or it just keeps going indefinitely. So it's saying question mark 1, 0. Why did bit become 0? Did it, maybe it overflowed? Yeah, it overflowed. So it said keep trying numbers. I mean, I guess I gotta just eat the wrong answers. Like, it's gonna just do random shit. There's no way this is right. So far, all this behavior is like about what I would expect. Well, let's say there's 7 numbers. And I'll say for myself, it's like 2, 3, 5, 7. What is going on with my handwriting? 1, 4, 6. This is all the numbers I care about. So first thing it's going to do is it's going to say, try every number, is it odd? Which means what I should return is 0, 1, 1, 1, 1, 0, 0. Is that what I'm supposed to do at the end? Yeah. What do you think of the question so far? I like it. I think the underlying question is creative, but I think that trying to fit this level of debugging into an interactive problem, like whenever I see interactive problems, I'm afraid that they're going to be this. I'm afraid that they're going to be like a bunch of weird bullshit to debug, and I'm like, please don't give me that. Please just give me like a thing I have to think hard about. Like that batteries problem from a while back was like a pretty good interactive problem. It's worse than many interactive problems I've seen. Yeah. The underlying thing is it's kind of interesting, but okay, so it's gonna say even, odd, 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 even, and then it's gonna say of all of these numbers, x is less than or equal to n. So it's going to say set bits is equal to 4 because you have 3, 5, 7, and 1. Yeah, exactly. It converges to 2n. Yeah. So then you choose the zeros. So the candidates now should be 2, 4, and 6. Does it correctly identify that? Yeah, it should, because it should say choose all of the numbers with a prefix of 0, which is 2, 4, and 6. So then it'll say, okay, skip these, they don't matter anymore. Does this have a 2's place? Yes. Does this have a 2's place? No. And the set bits is 2, because this does have a set bit there. So then it should say, but I actually need to keep track of this. So it should say 0, 1, 1, 1, 1, 0, 0, 1, 1, 1, 1, 0. There's no extra 0 here because it doesn't test 6 itself. And then I check the next row. So I should just say 1, 0. Right? Because it should take every index out of the running here. And I kind of want to actually just print here, like, print 0 and 0 and see if it's doing the right thing. That's going to like make it a lot clearer to me that it's at least trying to do the right thing. Okay, and then it'll say the number of set bits is 2, therefore this does have a set bit. So for the next row, it's going to just test this and say, does this have the 4's place? No. And then it should answer and say it's 6. Because it'll say, does it have the 4's place? It'll get back a 0. It'll say, push the 2 to the zeros. And then down here, it'll say, the set bits equals 1. O dot size is 0. Yeah. So therefore candidates is now empty. The prefix now gets a 4, so it becomes 6. And then candidates is empty. And then print 6. Will you do around 2162? I'll probably head out after this. I gotta take my dog out and stuff. So I think with this info, it should, well, let's see, 1, 0, and then another 0. With this, it should print out 6, I think. Or it'll do something really weird. 10. Where did it get 10 from? One, two, three, four, five, 6. It should really have a 7 in there. No, it shouldn't have a 7 in there because these are the indices that it cares about. By the way, there's a French competition with a very interesting problem. I can link it to you. Yeah. I'm down to look at it. So 1, 2, 3, 4, 5, 6, that's right. For I in candidates. So how on earth did a 10 make its way into the candidates? Where could that possibly have happened? Did I do like a plus somewhere? What's in candidates? Just a 10. What's in candidates the first time? 1, 2, 3, 4, 5, 6. So it said 1, 2, 3, 4, 5, 6. It said, okay, what about all these? Oh, well, I said O.pushback_X, not I. That's probably a huge part of the problem. And then it said there's 2 zeros and 4 ones, which is kind of gibberish at that point. So does this help at all? I said, okay, look at these. Are all these congruent with 1? It said in the zeros places 1 and 6, and in the twos places 2, 3, 4, and 5. Which, according to my own logic, is true. 1, 2, 3, 4, 5, 6. So it said, okay, this is what you're looking at, and this is what you're looking at now. Okay, and then it printed the candidates, which is now 2, 3, 4, and 5, so it's backwards. It looks like. Blah, 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 1 and 6, 2, 3, 4, and 5. It says there's 1 set bit, which is not right at all. There should be 4. One, two, three, four, five, 6, 7. So is it that I'm missing one? Let's see. If you only tested 6 and you're missing a 7th. No, that's not it. That's the whole point of this. 1, 2, 3, 4, 5, 6, 7. So set bits plus equals that. Bit and x equals bit. It's getting sloppy, but 1, 1, 2, 1, 3, 1. So it doesn't actually set these for any of them. Where did it even set bits to be 1? Am I crazy? Why is set bits equal to 1? Oh, maybe for the very first thing. Bit and x equals bit. So probably I should see 1, 0, and then everything else is 1. Yeah. So it said 1 and 1 equals 1. 1 and 2. I bet you it's like a stupid PEMDAS rule. Yeah, it was. It was a stupid PEMDAS rule. Okay, so now it's answering 6, which is good. So it said, look at all these. Now I have 1 and 6 in the zeros category, 2, 3, 4, and 5 in the ones category. There's 4 set bits. So ask about these. It's saying 6 is in the zeros category because that was a 4. 1 is in the ones category because that was a 2. There's 2 1 set bits, therefore this does have a 1 set bit, and I only care about the 1. So look at this and 4. This is in the zeros category, nothing is in the ones category, and now you're done. Okay. Could have costed me a wrong answer right there. One, two, 2, 1, 3, 1, 3, 2. Okay. 2 and 1. So it should say, is there a ones bit here? No. Therefore, take all the numbers that have a ones bit, which is 1. Wait, am I supposed to input n? Yeah, I am supposed to input n. Two and 1. So first thing it'll do is say, no, there's a 0 here. And then that's all it should have to say for this to print the right answer. which it does. Wrong answer, integer 0 violates the range from 1 to 3 in test case 2. I think I messed up the formatting. Wrong answer, integer 0. Oh, I just printed a 1? No, that looks fine. So maybe it's that I printed a 0? One, 3, 2. So it should say 1, 0. No, 1, 1. And then this should correctly identify that the answer is 2. But it says 0. So I don't just want to run it over with while there are candidates. I think I want to say while bit is less than or equal to n. And then it's going to test all of them. Okay. Looks good so far. I don't see how this could possibly TLE. This is n times log squared n, but that's kind of fine. Best time to buy and sell stock. Beauty of array B has the largest value bj minus bi over all pairs of indices I and j such that I is less than or equal to j. How and Alex play a turn-based game on array A of length n. Initially all elements of the array are unlocked. The player takes turns alternatively. Nice, there it is. On Howe's turn, he selects one unlocked element from A and removes it. On Alex's turn, he selects one unlocked element from array A and locks it. The game continues until all elements of A are either locked or removed. It can be proven the game lasts exactly n turns, and exactly n over 2 elements will remain locked in the array at the end. Howe wants to minimize the beauty of the final array and locked elements, while Alex wants to maximize it. Term the beauty of the final array if both players play optimally. Okay. So you want to... if both players play optimally. Is this one of these in the first 2 turns it's done thing? I think so. Because on Alex's turn, you're gonna... let's see, it's a lock, removal, a lock, a removal, a lock. There's no reason why you would ever not lock the BJ and BI immediately. So you do that. So that means there's 2 removals you have to care about. So does that mean you just choose the second best option? You say, what's the largest... you lock one of them in as BJ or BI, and then they delete one, and then you lock another one in. So if you have like this, and you have a 1 and a 9 and a 10 here, you really want to do that. And then you have a 2 and a 9, and then a bunch of 5s, who cares? I don't know what's up with my 5s today. So they would lock 1 or 10, it doesn't really matter. You would take 2. You really want that. If you took a 10 and they locked the 2, you'd be fucked. They lock the 10, you take the 9. So you need to know for any given number, is there a number after this that's greater than it? In which case, this can't be locked as the largest thing. So the 10, there's no number after it that's greater than it. Therefore, they would always lock you from playing this, right? I mean, not necessarily, though, because you could have something that's like 1, 2, 10. Did they say the length can be 3? I'm guessing, yeah, it must be 4. So if you had 1, 2, 3, 10, they're gonna lock the 10, and then it doesn't really matter what you do. It's gonna be at 2 adjacent elements. Is there any world where you don't just lock the largest one, where there's nothing larger after it, and the smallest one where there's nothing smaller before it? That's kind of difficult to like think about, but if you have a number where there's nothing greater after it, that doesn't really mean that much though, because you could have had an 11 here, in which case they would have wanted to have locked that. So I guess you go through once, you say, what's the best you could possibly do? Which is just, what's the smallest number I've seen at this point? And then you'd say, get that in a minute. Get that in 12 minutes. You'd say, what's the smallest number at this element that I've seen? Get the maximum, you know the first dude is going to make that not happen. So 1 and 11 is 100% not going to work out. And then the question is, would they have locked the 1 or would they have locked the 11? So I think you'd say, what's the second smallest element at this point? But then you'd kind of want to know what's the third smallest element too. Because then I think you might need multiple parses. This is my favorite Miyazaki movie. For a given element, can you use that? Do you even do that? What if you don't even do that? What if you just said, for every single element, choose this as your largest? Yeah, the guy's always going to either block the smallest and the second smallest, the smallest and the largest, or the largest and the second largest. There's 3 things the guy can do. And then you just go through normally, right? Not quite, because you get to choose one before they block the other one. So if they blocked the smallest, you get to choose. Here it wouldn't matter, but you get to choose, like, okay, and now this for sure is not getting blocked. So they don't get to just block any 2. But it's still a decision tree, right? If they block the smallest, if they remove the smallest, it's O of n to say, just clearly I want to do this. Like, I want to lock this thing in. And then well, if they block the smallest, you have 2 options. You lock in the second smallest, or you lock in the largest, and they're going to block the other one. And if they block the largest, either you're going to lock in the smallest, or you're going to lock in the second largest and then they block the smallest. I think it's just going to be like 4 if statements, right? And then you just play the game normally. And then you take the maximum of these 2. So if locking in the smallest and then they eliminate the second largest is better than locking in the second largest and they eliminate the smallest, then you take the smallest. You get to have a maximum of that, but then it's a minimum of whether eliminating the smallest versus the largest is better. No, I don't think that's right. That's not right. That's good in theory, but that's kind of assuming the array is strictly increasing, because you could have like 11, 1, 3, in which case like the largest one is just completely irrelevant. It doesn't matter. Still though, you could say for every element, for any x at I, there's going to be some y at j that was smaller than I that's like the optimal trade. So then you find the maximum. Is it at most once or 0 or? Yeah, you do have to choose, so you can't just take 0. So max of x at I and x at j across all I and j. So you take these, I think it's just the same thing as this though. Then you have the largest differential you can obtain. And then player one is going to remove xi or yj, and then you're in the next state down where player two is going to look through this board and say, okay, now I have xi1, I'll say, which is like second largest. Which is just the same as this. With those removed, they're going to lock in one of these. I think this is still wrong though, actually, because if you had a board that was like 1, no, that seems right. If you had a board that was like 1, 10, 110. What am I trying to illustrate here? They're going to eliminate one of these. That's just 2 choices, so you can just multiply the time complexity by 2. You're going to choose the next largest. I think it's pretty foolproof. I think there's no real way around it. It's just a minimum of 2 maxima. I think that's all it is. I think I ran out of time to code it out though. Yeah. Okay, we got that. So if player 1 erase x1, I'll say I1. If player 1 erase j1. So then I'm going to have a hash map. I'm going to say, or I'll just use a map, I don't care. Map int scene. I don't even really need that. I just need a minimum. For I from 1 to n, if a at I1 is minus a at j1, I'm going to say I'll say 1. If a at I1 minus a at j1 is greater than that, I1 equals I. If a at I is less than a at j1, j1 equals I. Okay, this will get you the largest return. Int j2, I2. You're going to have 4 results. And then in the end, it's going to be something like print min max x1, x2, max x3, x4. But it doesn't like that. Yeah, you're just going through it 4 times. Damn, there's no way I can do this in 1 minute and 30 seconds. I bet with 5 more minutes I could have done this. That's a shame. So if they erase I1, then for I want to say, okay, int j2 equals 0, I1 equals, no, I2 equals I1 equals 1 question mark 2 or else 1. So you're selling on turn 2 or turn 1. So for I from 1 to n, if a at I minus a at j2 is greater than a at I2 minus a at j2, now you actually need to record the maximum so far though. It's not good enough to just have I1 and J1. So I guess I'll say MSF equals 0 and 1. And then, let's see, this is kind of sloppy. This is kind of weird. I think I1 and J1. Can I record MSF with that? Yeah, I can, actually. So this is fine. I just need to say int j equals 0. So let's see, if a at I minus a at j is greater than a at I1 minus a at j1, it's saying if your current I and j are better, then I1 equals j, I1 equals I, j1 equals j. A at I is less than a at j, j equals I. Okay, cool. Kind of confusing. I'm gonna have I1, J1, I2, J2, X1, X2, X3, X4, but I actually don't think I don't think the logic is really confusing at all. So I think you can kind of get away with terribly readable code. If P1 erases I1, I'm saying there's gonna be a few different levels to this. So if a at I minus a at j is greater than a at I2 minus a at j2, I2 equals I, j2 equals j. So this is now going to be the second greatest difference. If P1 erase I2. J equals 0 for I in range 1 to n. Oops. I need to include, though, if I equals I1, continue. You don't get to include that. If I equals I1 or I equals I2, continue. You don't get to include either of those. J is 0, int x1 is equal to, I'm just going to say negative mod, I don't really care. What's that one? What's that one account name? Damn, C took me a really long time. Okay, I want to see if I can get E. X1 is negative mod. Oh, I wanted to check. This can go to 10 to the 9th, so you could get fucked and need to buy at 10 to the 9th and sell at negative 10 to the 9th. So I think I want this times 2, and then it's fine. Or I could just say negative infinity. Solves the problem. No, I don't want to do that. If A at I minus A at J is greater than x1, x1 equals A at I minus A at J. And then I could have this be negative infinity. J equals that, if something J equals I. Leetcode. I wonder how that Leetcode contest came out. I wonder if I really just got 165. That's so funny. If A at I is less than A at J, J equals I. So if P1 erases I2, you get this. If P1 erases J1, you get X2 is negative infinity for I from 1 to n. I mean, it's just going to be this again, basically, but slightly different. Now it's if I equals I1 or J equals J2. Are you into competitive programming or doing it for interview prep? I'm just into it. I just find it fun. I like watching people on Twitch play like Dota or like Risk of Rain or something, but I just really like watching people figure these problems out. I just think it's interesting, and it's honestly a pretty good way to socialize. Like, people that are good at this stuff are sometimes a little chronically online, but sometimes they're pretty chill. If I equals I1, J equals J2. I think there's only 3 cases actually, because if P1 takes away I1, no, there's not. I need to have all 4. It's pretty important. If I1 equals J1 or if I equals I1 or J equals J2, so this is the world where you said, now that you've gotten rid of I1, I'm just going to come up with the next optimal J, and you're going to try to get rid of that. So that's J2. This is X2 equals 8i minus 8j. If 8i is the same as j. Okay, great. And then there's if player 1 erases J1, which is going to be very similar to all of this. So I'll say the new J2, 0, we got that, but now I'm going to say if J equals J1, continue. This keeps going. You set the optimal I2 and J2 now. So now if player 1 gets rid of I1, this will be X3. So keep going. Now no. If they get rid of I2, that's actually pretty important. If I equals I, let's see, if J equals J1 or I equals I2, continue, or else do all this. This is X3. Okay, or if they erase J2, we got X4. This is J equals J1 or J equals J2. Yeah. 4, 4. Okay. I like watch people LC as well. There's usually 2 types of people. The ones who solve the problem before writing code and the ones who start to write code and figure it out along the way. Well, you're not the first person to have said that, but I go either way. I don't know. I think a lot of the time I do kind of just solve it in my head, but like I'm not going to explain it all. Like right here, I'm like, I feel like I pretty concretely, like with pen and paper, was like, okay, it's this. But I'm like, I am timing myself, and like I don't, like if someone's going to ask, then I know someone's paying enough attention to like care about the specifics of my words. But if no one's like, I'm not going to like spend half an hour being like, and then in this contingency, you know what I mean? Yeah, I got D. I almost got E. I mean, if this works, I was pretty close. But I gotta do some debugging. Negative 99998. Shit. 1, negative 2, 5, 3. So I got 1, negative 2. This is a random number. I think what's going on with this 3 is the negative infinity is probably fucking it up. This says if a at I minus a at j is greater than x4, I think a really simple fix is just change a to be LLs. I don't think time complexity is going to be much of an issue. Negative a giant number for the 4th one. So what happens? Probably player 1 gets rid of 5, and then you buy 1, sell 4, and then player 2 says, I'll keep the 1. It really doesn't matter. And then player 1 gets rid of a 4, and then you, no matter what, you can still buy it 1, sell it 4. So the answer is 3. So why would mine come up with negative a giant number? This looks like a familiar number, and this looks like the number of when I just happen to know it, this huge prime that I uses overflows with integers. Have you tried my link? No, I was pretty close with this one, so I wanna, or at least pretty close with this proposed solution, so I kind of want to see it through. Same, I'm almost not even interested in the implementation deals. It's the boring part. I go back and forth. I was just talking to someone about this. There's something almost freeing about when you get obsessed with like data-oriented design and the like tiny little implementation things. Like it's annoying when it's like a long overflow in int or something, but I guess I'll just look at specifically test case 3. I gotta just get into it. Oh, test case 4. Test case 3 is also wrong, but I'm less curious about that right now. I think the first thing to check is just... So we got 3 and a bunch of negative numbers. So these never even showed up. I solve it before I code, and then I realized while coding that I was wrong all the way, and I started again. That's actually, like, honestly, yeah. I think that's why I don't dedicate too much time to this, because I'm like, I mean, if I have a thing that I'm pretty confident will work to the extent that I can imagine it, like, I would rather just get that down and then see where it goes wrong compared to, like, putting more eggs in that basket. Same, I'm almost not even interested, but then I'm only using it to prep for interviews where comms and approach are more important. Yeah, it's a weird hoop. I think probably in terms of like the ratio of importance to amount people want to do it, I think Leetcode is like up there. But in terms of importance, I still think probably just like years of experience and the general impression you give is more important. So all of these x1, x2, x3, x4, these are all negative infinity except for x1, which is odd. Like, what about x2 is really all that different than x1? Okay, so x2 was never set. Is it that, let's see, 1, 2, 3, 4. It's certainly not that this is too small. So this never went through. Okay, I think, well, let me think about this. X1, I1, J1, I1, I2, I1, J2. This should be J1, I2, J1, J2. Does it even go through this loop at all? Yeah, it does. Or J equals J2. I see. So the problem is that J2 is being set randomly. I don't want that. I want J2 to just be like the first thing that's not, or J to be the first thing that's not. So first off, I'm not resetting J. That's like a dumb mistake, so I gotta go back and do that. Or at least here I'm not. The other ones I did for some reason. J, J, J. Okay, I've now reset J for all of them, at least that. But there's another problem, which is that it's not actually just 0. Here it's 0 because I1 and I2 could not be 0. So that just happens to be 0. But here, I need to just say something that's like while J doesn't equal I1, or no, while J equals I1 or J equals J1, J++. And then this is just J plus 1. And with that in mind, I think I can just kind of copy this out. And now it'll like actually give the right answer for, or at least it'll solve this problem. And that probably was a lot of the issue with the other test cases as well. So let's see, I'm bringing it down here. If there's more I have to do, actually. I'm going to undo this copy. So I'm saying keep going up until you're not at I1 or J1, because those are the numbers that are blocked out. And then here, if I equals I1, continue. Or I think just straight up, or I equals J1. Yeah. So here you're erasing J1. So I just need to say if J1 equals J, J++. And then if I equals J1, continue. You've blocked that, so you can't use it. Okay, here. If J1 equals J, J++, or no, while J equals J1 or J equals I2. Yeah, let me double check this. I think this should be J2, but I'll go back to that in a second. While J equals J1 or J equals I2, J++. If I equals J1 or I equals J2, continue. Okay, that looks good for that. So I'm saying just completely ignore J1 and J2. Which is what this should do. Except they need to say J+1 for all these. And I'm just going to have that be a standard. Okay, but here J1 represents the original optimal choice. That doesn't, but J2 is the new optimal choice. So this needs to be if it erases J2. So while that, J2. If I equals I1 or I equals J2. Okay, I think that's all I have to do there. So let me read this back. Or just run it, I don't care. 3 is the correct answer. And I think no matter what you do, it will always be 3. That's a good sign. 1, -2, 5, 3, 1, big negative number. I'm just gonna kind of roll with it. Have you done the Meta Hacker Cup? No, not yet. I'm gonna be pretty happy if I can get this one. I'll be really happy if it works like here, but nah. If this completely throws off my thing, 26th numbers differ. Expected -1, found 0. Are there 26 test cases here? I doubt it. That means there'd have to be like 104 if this is double spaced. Okay, there probably are. Yeah, probably. It's supposed to be hard, this problem. Let's see, if test case doesn't equal 26, return. Okay. So what happened here? One, two, 1, 1. So this is saying actually optimally it's a -1. So you could I think I see why it would be -1. If it used to be easier to get Grandmaster, yeah, for sure. I think I did the problem after that sparse table problem. Yeah, this was like 2400, and then the one after it was not that bad. It was not that bad, and this was 2700. It was pretty wacky. Okay, so let's see. They delete this 1. You no longer are able to have the 1 and 2. My code does support that. So then you'll just have 2, 1, 1. And then player 2, let's say, will lock in the 1. They're like, I don't want anything to do with this 2. I want to buy this 1 and sell this 1. So they lock in this 1. And then player 1, now it's their turn to erase something. They erase this 1. You now have to buy at a 2 and sell at a 1. And my code's not doing that for some reason, but my code should do that. So for these, it should be 0, because this is where player 1 deleted the 2, but actually they can do better. Interesting, so we have -1 but 0. So this is wrong. This is saying, no, this is not wrong. Is it just a min of all these? Min, max, max. So this x4 here, this 0 is saying player 1 identified, hey, I can buy at a 1 and sell at a 2. I make a profit of 1. Player 2 said, no, you can't buy at this 1. Now you're at 2, 1, 1. And then player 1 said, I can buy at the 1 and sell at the 1. And then player 2 said, no, I'm going to get rid of one of these 1s. And now you have to buy at a 2 and sell at a 1. For some reason, it didn't recognize. It might just be a typo, but I'm kind of questioning. Yeah, what exactly is the problem? Well, j equals j1 or j equals j2. J++ for I in range j plus 1 to n. This looks fine. And subtract 400 elo. Yeah, probably. So it said when you're at index 2, the answer is -1. Well, I'm just curious, like, what the hell are J... What are J1 and J2? I'm guessing they should be like 1 and 2, or 0 and 2, or 0 and 3. Does this mean 0 and 0? That should not happen. So that tells me there's probably an error with this code. Yeah. Yeah. J2 is not 0. J2 is going to be equal to J. I2 is going to be equal to... I guess J plus 1. I think that's fine. So now I think I should get, this should say 0 and 2 or something, okay. It's a dumb little typo. 'Answer expected output'. No, not the answer. Zero, bunch of ones, 0, 1, 2, 2, 0, 1, 2, 3. Zero, 1, 2, 3, 4, -1, a bunch of zeros. Okay, yeah, that seems right. At least for the first 30. Come on. Fuck. 276 numbers. Alright, well, it's going to be looking for a typo or else it's completely wrong. I don't see how this could be wrong, though. I don't see why you wouldn't do one of 4 things. So if they erase I1, I guess I'll say J equals 0 if J equals I1, J plus plus. J2 equals J. I2 equals J plus 1 if I2 equals I1, I2 plus plus. For I from J plus 1 to N, if I is I1 continue, looks good. Okay, x1. So you've gotten rid of I1 and I2. While j equals I1 or j equals I2, j plus plus. If I equals I1 or I equals I2, continue. This looks good. Okay, or j2. Well, j is I1 or j2, j plus plus. If I is I1 or j2, continue. Okay. If player 1 erases j1, so j is 0. If j1 is j, j plus plus. j2 is j, I2 is j plus 1, but if I2 equals j1, I2 plus plus. Okay. For I in range, if I equals j1, continue. x3, j is 0, while j is j1 or I2, j plus plus. If I is j1 or I2, continue. x4, if j is j1 or j2, j plus plus. If I is j1 or j2, continue. Okay, well that kind of rephrased it a little bit, but I don't really know. I doubt that really changed the logic a whole lot. Like it did, but it was all logic that I saw as pretty unimportant. No, same thing. So what's a world where you can force a -2? And mine isn't accounting for that. I really can't think of one. I mean, there's really only 4 options. There's you delete the largest thing. No, I think there's more than 4. You would need to delete one of the largest options. Because here, you could have, if you have a height map of the options, you could have like, well, actually this is pretty important. If you have a height map and then you have like a small and then a large and then a large over here, you could have another small over here, or some option where you wanted to delete this, but mine would have you delete this. But this is further forward, which is purely less advantageous to delete. So I think what I would want to do is say, if A at I is, that's fine. For finding I1 and J1, I want to say if A at I minus A at J is greater than or equal to A at I1 minus A at J1. And then here I'm saying find the optimal. You want the minimum J with the maximum I. And then that should be the final one. Very slight change. But I could actually, that's like a change I could actually see affecting the outcome. Nah, damn. Oh well. I think I'm just gonna have to look at what I did wrong. Alright, I gotta call this person back and make some food. I've been going for a minute. I think Solaris, I'll like, if you're still there, I'll message you about the problem you sent. Alright, see you guys.